how many 3's are there? For that, the last term, that is 99, is equal to a plus n minus 1 whole into t. We can start solving the sum by taking the numbers as usual: a plus d, a plus 2d, a plus 3d. But since the sum is given, I am going to use the technique, the 4 numbers in AP. Let me start. In the first case, we have to show these numbers are in AP. One by root b plus root c, 1 by root c plus root a, 1 by root a plus root b. Welcome to btosacademy. Welcome to my maths class. Today I am going to continue the topic AP-GP. Actually, I shall work out more sums on AP and GP. Already I have taken 2 sums on the board. I start. There are in arithmetic means in between 40 and 4, and ratio of first mean and last mean is 2:9. We have to find the value of n. Given numbers 4 and 40. If D be the common difference of the means, then 40 will be the n plus 2th term of 4, m1, m2, mn, 40. Therefore, 40 is equal to 4 plus number of terms in this case n plus 2. Therefore, n plus 2 minus 1 into d, that is equal to 4 plus n plus 1 whole into d. Therefore, n plus 1 whole into d is equal to 40 minus 4, 36. Now, ratio of first mean and last mean. Here, first mean is equal to 4 plus d that is m1, and last mean will be d less than 40, that means 40 minus d, that is the last mean. As per sum, 4 plus d by 40 minus d, that is given 2 by 9. Now this equation involves only the unknown t. We solve 36 plus 9d 80 minus 2d. 90 plus 2d is equal to 80 minus 36, or 11d is equal to 44. From that, d equal to 4. Therefore, we get the common difference. Now we put this value here. Let me call this 1. Putting d equal to 4 in 1. n plus 1 whole into 4 is equal to 36. Therefore, n plus 1 equal to 36 by 4, 9. Therefore, n equal to 9 minus 1, 8. Therefore, there are 8 arithmetic means in between 4 and 40. Therefore, there are 8 in short m in between 4 and 40. The sum is solved. Next sum, we have to find the sum of the integers divisible by 3 or 5 in between 1 to 100. Numbers or integers divisible by 3 in within, I write within within 1 to 100 are 3, 6, 9, 12, 99. Before 100, the number divisible by 3 is 99. Integers divisible by, we are first writing down the numbers which are divisible by 3, then by 5, then by 3 and 5. Divisible by 5 within 1 to 100 are 5, 10, 15, 20, 95. Integers divisible by 3 and 5, that is 15, are 15, 30, 45, 90. if is1, is2, is3 be the sums of numbers in cases of, I call this A, B, C. A, B and C respectively, then is 1 equal to 3 plus 6 plus 9 plus up to 99. Is 2 equal to 5 plus 10 plus 15 plus up to 95. Is 3 equal to 15, 30, 45 up to 90. Now we have to calculate how many 3's are in between 1 and 100. For that, for is 1, 99 is equal to 3 in 1 minus, here the common difference is 3. From that, 3 in minus 1. I have applied here the formula a plus n minus 1 whole into t. I don't know how many 3's are there. For that, the last term, that is 99, is equal to a plus n minus 1 whole into t. Separately, we have to determine how many 5's are there in between 1 and 100, how many 15's are there in between 1 and 100. For S2, $95. Separately, we have to calculate the number of terms. While we shall apply the formula for sum, we need this. Therefore, I have found. Now, is 1 equal to 33 by 2. In by 2, within brackets, 2a plus 33 minus 1, 32 into 3. 33, I divide both by 2. then it will be 3, it will be 48. 32 divided by 2, 16 into 3. (51), 33, I get the product 3, 1683. Then S2 19 by 2, 2 into 5 plus 18 into 5. That means 19, 5 plus 45, 19 into 50, 0, 950. I need space for that. I have here S3 will be 6 terms are there which are divisible by 15 in between 1 and 100. A plus n minus 1 into d, this is. (105 into 3). (105 into 3), 315. Therefore, required sum S1 is the sum of numbers in between 1 and 100 which are divisible by 3. Therefore, first S1, then S2, those numbers, each of those are divisible by 5, S2. Now, while we are considering S1 and S2, there are numbers which are divisible by both 3 and 5. That sum is to be subtracted, that is, required sum will be S1 plus S2 minus S3. Now I put the values. S1 already we have got 1683 plus 950 minus 315. Now we calculate 3, 3, 3, 315. The required sum will be 2318. Let me discuss again. We have to find the sum of integers which are divisible by 3 or 5 in between 1 and 100. For that, first we have to consider the numbers which are divisible by 3. Those numbers are 3, 6, 9, 12, dot dot dot. Before 100, number divisible by 3 is 99. And I have taken some of those numbers as S1. Therefore, S1 equal to 3 plus 6 plus 9 dot 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 plus 99. Then numbers in between 1 and 100 divisible by 5. I have called the sum of those numbers as S2. Then S2 equal to this. And numbers already, while we are considering S1 and S2, we have already considered the numbers which are divisible by both 3 and 5. We have to subtract that sum, and that S3 equal to this one. Therefore, required sum, after that we have calculated the number of 3's in between 1 and 100, number of 5's in between 1 and 100, and number of 15's in between 1 and 100 divisible by actually. Then we have got the sums S1, S2 and S3. Then the required sum is this. This is the answer. Students, learners, you note how we are solving the sums. Try to follow the process, the method by which we are solving. This sum is finished. The sum of 4 integers in AP is 24 and their product is 945. What are the numbers? Similar sum, I discussed one sum, but those were 3 numbers, but I have taken here 4 integers. First of all, we can start solving the sum by taking the numbers as usual: A plus D, A plus 2D, A plus 3D. But since the sum is given, I am going to use the technique, the 4 numbers in AP. Let me start. Let the 4 integers in AP be A minus 3D, A minus D, A plus D, A plus 3D. Follow the technique. You see, the difference between these two is 2D. Difference between these two is also 2D, and difference between these two also 2D. While the numbers are in 4 numbers, then we use the technique, this one. We can also follow that normal rule: A plus D, A plus 2D, A plus 3D. But sum is there, therefore we take the numbers like this. Now you follow, if we take the sum, then these will be cancelled. Then we shall get the value of A first. Therefore, as per condition, A minus 3D plus A minus D, A plus D, A plus 3D, 24. We simplify. A 4 is there. A is equal to 24. Therefore, A equal to 24 by 4 is equal to 6. And the second condition is their product is 945. A minus 3D, A minus D, a plus d, a plus 3d is equal to 945. Using the first condition, already we have got the value of a. Then according to the second condition, product is 945. Therefore, or I put the value of a minus 3d, sorry, 6 minus 3d. I take these two first, 6 plus 3d into 6 minus d into 6 plus d, that is equal to 945, or 36 minus square into 36 minus d square is equal to 945. Now both of these are divisible by 9, therefore 4 minus d square into 36 minus d square is equal to 945 divided by 9. Therefore, we get this equation. Now we have to solve, or 144 minus 40 d square, 36 into d square, 36 d square, 4 into d square, finally minus 40 d square plus d to the power 4 is equal to 105, or d to the power 4 minus 40 d square plus 144 minus 105 equal to 0, or d to the power 4 minus 40 d square plus or d square minus d square whole square rather minus 39 d square minus d square plus 39 equal to 0, or d square minus 39 into d square minus 1. Zero. Therefore, d square minus 39 equal to 0, d square minus 1 equal to 0. From we get d equal to plus minus root over 39, and from this we get d equal to plus minus 1. Now the given numbers are integers. We have to mention that since required numbers are integers, therefore d cannot be plus minus root over 39. Therefore d equal to plus minus 1. When d equal to 1, required numbers are d equal to 1. Numbers are these. 6 minus 3, that is 3. 6 plus then 6 minus d, 5, 7, 9. 3, 5, 7, 9. When d equal to minus 1, required numbers are minus 1, a, actually numbers will be in reverse order. Numbers will be same but in reverse order. Remember, both are to be mentioned. Though numbers are same, but the order reverse, but we have to mention this. Therefore, the sum is solved. Next sum, ABC are in AP. Then we have to prove this. Actually, I discussed few sums in the earlier episode. I have taken also more sums here. A, B, C are in AP. Therefore, B minus A is equal to C minus B, and we can take B equal to A plus K, C equal to A plus 2K. K common difference. Now, in the first case, we have to show these numbers are in AP. One by root B plus root C, 1 by root C plus root A, 1 by root A plus root B will be in AP. First of all, we rationalize each. That means root B minus root C by B minus C, root C minus root A by C minus A, root A minus root B by A minus B will be in AP. That means we have to show these three will be in AP. For that, we first take the sum of these two. Now, root B minus root C by B minus C plus root A minus root B by A minus B. You see, already we have taken K as a common difference. Therefore, also we can apply this one, B minus C, that will be equal to A minus B, root B minus root C by A minus B plus root A minus root B A minus B. B minus C, from here, if I multiply both sides by minus 1, then I shall get B minus C equal to A minus B. So that new denominators are equal, therefore LCM will be A minus B. Root B minus root C plus root A minus root B. root a minus root c by a minus b. Now we have to show sum of this is double of this. For that we simplify this one like this, c minus a, that is equal to 2k, and root c minus root a by c minus a, that is equal to root c minus root a. From this relation c minus a equal to 2k, we put that value. Again, k is equal to b minus a, root c minus root a by 2 into b minus a. That is equal to, multiplying both numerator and denominator by minus 1, we get. Now we compare these two. You see, there is 2 at the denominator, therefore we can write, therefore root b minus root c by b minus c plus root a minus root b by a minus b is equal to 2 into root a minus root c by a minus b. Or we can write c minus a. Better we write this one. Root c minus root a by c minus a. That is of the form, if PQ be in AP, then P plus R will be equal to 2Q. Therefore we can conclude 1 by root B plus root C, 1 by root C plus root A, 1 by root A plus root B are in AP. Root. Follow the method. First of all, we have rationalized each, then we have shown sum of the first and last is equal to double the middle. We have calculated sum of these two and get the form this one. Then we have simplified the middle one and get this one. After comparing, what we find, this is double of this. That means sum of these two is double this. From that, the conclusion is this. The sum is solved. Second part, left hand side a minus c whole square, right hand side 4 into within brackets b square minus ac. We calculate separately left hand side as well as right hand side. LHS a minus c whole square. Now a minus c, from here we get minus 2k, that is 4k square. Then RHS 4 B square minus AC. We put the values 4 B equal to A plus K. A plus K whole square minus A, value of C is A plus 2K. Now we simplify, A square plus K square plus 2AK minus A square minus 2AK. Now these are cancelled, equal to 4K square. We get both 4K square, therefore LHS equal to RHS. Therefore A minus C whole square 4 into B square minus AC.